In this video, we're going to learn about the sphere. So before we get started on finding the volume of a sphere, just a couple different definitions and vocab that we need to talk about. So first of all, a sphere is like a ball. It's a three-dimensional figure such that all points on the surface are equidistant from the center point. So it is not a polyhedron because it has no straight edges or no polygons. It's completely curved. When we talk about finding the cross section of a sphere, so basically slicing a sphere, well, when we do that, we will get a circle. So anywhere I slice this, I'm going to end up getting a circle. Um, the great circle, so if the center of the circle is also the center of the sphere, then the circle is called the great circle. So basically think about if you were to slice right through the center, so there's lots of different ways to do that, but as long as the center of your cross section is going through the center of the sphere, well then that means that circle that you're creating is called the great circle. It's the biggest circle that you can create from the sphere. And, that's kind of, again, going over here. So great circle is the largest circle. An example, the equator on the Earth is an example of a great circle. And it divides, so a great circle divides the circle into two hemispheres. So two hemispheres, hemisphere meaning half of a sphere. So that's important because if you see a hemisphere, you need to remember, okay, well, that means half of a sphere. So you would divide, if we're trying to find the volume of a sphere, you could divide it by 2 to find the volume of a hemisphere. And just some other things here. So the shortest distance between 2 points on a sphere is along the arc of the great circle joining the points. Great circle is an example of a geodesic. It's the shortest distance between any 2 points on a surface. So again, that's just kind of going a little bit above and beyond, but let's go into volume. So volume, here's your formula. So this is provided on the reference sheet. So we will leave in terms of pi unless the directions tell us to round. So leaving in terms of pi is your exact answer. That's the best answer that you can provide. Versus if the directions tell you to round, well then you're really giving an estimate and you will round if the directions tell you to. So the big thing here is to notice that it's to the third power. Naturally, our brains think pi r squared because we're used to seeing area of a circle as pi r squared. So it's very easy just to kind of continue that thought as pi r squared. But just keep in mind that it's cubed because we're talking about volume. We have to cube that dimension, that radius. So let's go ahead and use that formula. So find the volume of a sphere whose diameter is 12 inches. So the first thing is if I want to draw this picture, just to make it look three-dimensional, we kind of put this oval shape in there. And it says that the diameter is 12 inches. So be careful that that really means that the radius is half of that. So the radius is 6. So when I write my formula, so volume equals 4/3 pi r cubed, and again, check that and be very conscious of making sure that you're writing cubed and not squared. So volume equals 4/3 pi, and then I'm going to plug in 6. And for this one, I am going to use, I'm going to leave in terms of pi since it doesn't tell me to round. So all I'm typing into my calculator is 4 divided by 3 times 6 caret to the third. So let me actually show you that. So in my calculator here, I'm typing in 4 divided, oops, let me press the home screen first. So 4 divided by 3. Or you could do, if I don't want to type it in like that, if I hit Control Divide, I'll get the fraction. So sometimes people prefer that. So 4/3. And then I'm going to do times the radius, or in parentheses, 6 to the third. So this caret key will let us raise it to the third. Hit enter, we get 288. So notice that I didn't put pi, but then when I go back to my notes here, my answer is going to be 288 pi inches cubed. And that's it. So we're leaving that one as an exact answer. So this is considered an exact answer. The directions didn't say to round, so that is the best way that we can provide our answer. For number 2, it says the volume of the sphere is 5,000 cubic meters. So now they're giving us the volume. We want to find, to the nearest hundredth, what is the radius. So now we're trying to find the radius. So for this one, we know that the volume of the sphere is equal to 5,000 meters cubed, and I don't know what the radius is. So that's what I'm going to find. So I'm going to go ahead and write my formula. We always want to show that formula first. Remember that it's cubed in the formula. So plug in what you know. So we know the 5,000 equals 4/3 pi r cubed. So basically what we need to do is we need to get the r by itself. So there's two ways you can do this. You can divide over, or really there's 3 different ways, because I could multiply both sides by the reciprocal of this. So I can multiply by 3/4 on both sides to get rid of that fraction. I can divide over the 4/3 first and then divide over the pi, or you could divide everything at once. I can, because this is all multiplication. So what I can do is I can divide both sides by 4/3 pi. What you need to be careful with, though, and I'll show you this in the calculator, is you need to be careful that when you divide this in the calculator, that this is truly in the denominator, that you're dividing by both pieces. So putting that in parentheses is important, or using that control divide feature. So let's just do that. So I have 5,000. Control divide, we'll make that a fraction. So 5,000, and then in the denominator, I want 4/3. So what I'm going to do for this is I'm actually just going to do 4 divided by 3 instead of putting in using control divide again. You could use control divide again, and then in the pi keys down here. And notice how those are both in the denominator. That's important. So I get this number. 5,000, you could also just divide, but you'd have to put parentheses 4/3 pi. That's going to give you the same thing. If you're not careful, and like let's say I just do 5,000 divided by 4/3 pi, what ends up happening is I'm getting a totally different number. So you have to be careful to make sure that the 4/3 pi is all in the denominator. So we get this 1,193.66. So let me go back. Oops, 1,000, okay. All right, there we go. So 1,193.66 equals r to the third. And I know that there's more decimals there, but I'm not going to worry about that yet. Now what I need to do is get r by itself. So to get r by itself, it's being raised to the third. So what I'm going to do is I'm going to cube root both sides. So cube root. And that's going to get me r. So let's go ahead and do that in the calculator. So what I'm going to do is over here, I see above the caret the nth root. So I'm going to go ahead and do control caret to get that. I'm going to put the 3 out in front to indicate the cube root. And then I'm going to go up top here, and I want to enter that number. So notice how I did that. I had the cursor underneath the root, and then I went up and I selected the number I wanted so that it dropped it right into the place I wanted. So I'm getting 10.6078. So when we want to round to the nearest hundredth, 2 decimal places, so the radius is equal to 10.61, and we're talking about meters. So that's it. So again, do not round till the end when you're doing these. Make sure that you go up and you use the values right from your calculator. And use as many decimal places as possible until the final answer. So go ahead, go to the next page, fill out your key ideas, and complete the check your understanding problems.